So these are going to be some trigonometric proof questions. Um, these when you get these in an exam, they're usually towards the end. And they're split up into multiple parts like this, and they are about marks. And students can often get pretty confused with these sort of questions because it is a lot more open-ended. Um, it's not about just finding an answer. It's more about showing that something is true, or the whole marking, or the whole point of the answer is the working, is to show how you've got the answer, how you've proved something. So it can confuse a lot of students, but what I'm going to show you in this sort of step is how you can use the fact that they usually break these questions up into multiple parts, and the wording of these questions. I'll show you little hints and tricks that you can use that can make these questions a bit easier, and just try to maximize the marks you can get out of these questions. So over here in the first question, we've got an acute angle, and they've given us a ratio. Now we have to do a couple of things. We have to find the length of an unknown side. We have to find the exact values of sine A and cos A, and then we have to show this equation is true, that sine squared A plus cos squared A is equal to 1. Okay, so the first thing we're going to do is, if you look at part A, it asks us to use Pythagoras theorem to find the length of the unknown side. So the first thing we're going to do is we're going to draw up a triangle and sort of just visualize this information that they've given us. Okay, so I've made this diagram here, and I've got this angle A here. It's an acute angle. Let me just rub that out. So we've got an acute angle A here, and we know that tan A is equal to root 5 over root 2. Now recall that when we have the tan ratio, tan refers to opposite over adjacent. So that means that this root 5, this must be opposite the angle, as you can see here. And this side of 2, this must be adjacent to the angle, 2, which is over here. And therefore, that means that the unknown side we need to find, I've just labeled as x, that unknown side is the hypotenuse, okay? Now, this is just a simple Pythagoras theorem question. So using the formula c squared is equal to a squared plus b squared, we get that x is equal to 3. So that's the length of the unknown side. So now we have all three sides here, okay? So we know that this is, sorry, let me use a different color. I don't know why I've done that. So we've got all three sides already, as you can see. We've got root 5, 2, and x is equal to 3. Okay, now looking at the next part, it says, hence, write down the exact values of sine A and cos A. Now, this is when I'm giving you a hint, and also something that you should remember is when you have a multi-part question like this, and the wording says hence means that you need to use whatever you found in part A to answer part B. And that's not like sort of like a like an option. It's mandatory to do that. It's you have to. If it's saying hence, that means you must use something that you figured out from answer A to figure out your answer B. If you don't, you're probably going the wrong track, and you're getting your answer wrong. Sometimes they'll say hence or otherwise. Then you can figure out your own way of doing it. But if it says hence, it means that you must use your answer from part A to figure out part B. And in this case, it will be because we need to find the values of sine A and cos A. And if you recall, sine A is opposite over hypotenuse, and cos A is adjacent over hypotenuse. So in both these instances, we will be needing the length of the hypotenuse, which is basically what we found in part A. So what we're going to be doing is sine is just opposite over hypotenuse, which is root 5 over 3, as we can see here. And cos A is just adjacent over hypotenuse, which is again 2 over 3, as you can see here. Okay, so we've used what we've found in part A to answer part B, so that's good. Now the final part is just showing that this is true. Okay, and what we do is we always start with the left-hand side, or you can start off with the right-hand side on some equations, but there's really nothing we can do with one, right? So we will mistake on the start off with the left-hand side first here, and we're going to show that sine squared A plus cos squared A is equal to 1. Okay, so we know sine A and we know cos A. So if we want to find sine squared A and cos squared A, all we have to do is we have to just square these numbers that we've gotten, right? So sine squared A is root 5 over 3 squared, and cos squared A is 2 over 3 squared. And if you put that in your calculator, you will get 1, which is equal to the right-hand side. And that's how you show your proof. So yeah, if you would immediately if the question was just to ask you this, it's obviously you want to be like, where do I start? It can be a bit confusing, but they'll usually break it up into multiple parts like this, providing you a framework of sort of how to figure it out, and it'll make sure that you're staying on the right track. Next question is a similar question now. So we've got B as an acute angle, and now we've got sec B. Okay, so this is a trigonometric ratio you may or may not have heard before, but we'll have a look at that one as well. And then it's a sort of similar question. From here, we're finding the exact values of cosec B and cot B, and then going to show that this theory is true. Now, what these ratios are, you may have heard these ones, you may not have. These are what we call the reciprocal ratios. Okay, so I've written that down here. So sec B is equal to 1 over cos B, cosec B is equal to 1 over sine B, and cot B is equal to 1 over tan B. Now, the way to remember these, or the way I like to remember these, is we look at the third letter of each of these ratios. So sec, the third letter is C. So this is the reciprocal of the cos, C for cos. This one, the third letter is S. So we take the reciprocal of the third letter, right? S for sine. Then the cot, the third letter is T. So this is the reciprocal of the tan ratio, right? T for tan. Yeah, that's how I remember it, and it might be useful for you as well. Now, since we know that cos is adjacent over hypotenuse, the reciprocal of that would be hypotenuse over adjacent, similar to sine, right? If sine is opposite of a hypotenuse, the reciprocal is going to be hypotenuse over opposite. And if tan is opposite of adjacent, the reciprocal is going to be adjacent over opposite. Okay, now using that information, we know that sec B is equal to root 11 over 3, which means that the hypotenuse over the adjacent is equal to root 11 over 3. So if I've got my angle beta here, the hypotenuse has to be root 11, and the adjacent side has to be 3. Okay, then again, using Pythagoras' theorem, we've figured out that this unknown side here is root 2. Okay, x squared is equal to root 11 squared minus 3 squared. Now from that, we can figure out what cosec B and cot B is. So cosec B is hypotenuse over opposite, which is root 11 over root 2, and cot B is equal to adjacent over opposite, which is 3 over root 2. Now, if we find part B, which is to prove this, cosec squared B is equal to root 11 over root 2 squared minus 3 over root 2 squared, which is 11 over 2 minus 9 over 2, which in the end equals to 1, and is equal to our right-hand side. And therefore, we have proved that as well. Okay, so similar sort of question there as well. Now, the last question, it's a bit different. Now, without using the calculator, we want to show that 2 tan 30 over 1 minus tan squared 30 is equal to tan 60. Obviously, if you put this in your calculator, you can show that left-hand side is equal to right-hand side, but we actually need to show how it's equal. So that's why they've specified without using a calculator. So what we do with these sort of questions is we look at these special triangles. So these two triangles are called the special triangles. And you'll see these a lot when you get into year 11 and 12. If you're doing high level maths and you get a formula sheet, these are pretty standard. These are usually in all of the major formula sheet. If you're taking your board exams in Australia or India or the UK, wherever, this will, if you have a reference sheet, if you do have a formula sheet given, then this will usually be on there. And we're going to use this to solve this equation. So we're going to start from the left-hand side again. Our left-hand side is 2 times tan 30. Okay, so if we look at tan 30, we've got the angle of 30 here. We know that tan is opposite over adjacent. So opposite is root 1 over root 3. Okay, so we've done 2 times 1 over root 3 minus 1 over root 3 squared. Okay, now that is equal to 2 over root 3 divided by 1 minus 1 over 3. Okay, so I've just squared this. Now if we just put this into one fraction, 1 minus 1 over 3 becomes 2 over 3. And that becomes 2 over root 3 times 3 over 2. The 2 over 2 cancels and we get 3 over root 3. And if you rationalize that, you'll get root 3. And if you look at tan 60 is equal to root 3 over 1, which is the right-hand side. So therefore, that is also proven. So then that is the way of showing these proof questions. You always start with the left-hand side or the right-hand side, and you keep on going until you get to the other side. And you have to explicitly show that, like I've shown here, that LHS is equal to RHS, or RHS is equal to LHS, showing that is very important.